So module 4, title of the module 4 is two variable calculus. So topics of this module is limit and continuity, partial derivative, directional derivative, total derivative. These three regarding derivatives, maxima, minima, and saddle points, method of Lagrange multipliers. Today we are going to discuss about limit and continuity. First of all, what is a two variable function? Two variable function means function depends on two independent variable f of x comma y. Here x comma y are independent. Z equal to f of x comma y. In the single variable function y equal to f of x. By giving x value, we get y value. Here by giving x comma y value, we get z value. Best example, area of the rectangle. Area of the rectangle equal to length into breadth. Length is one variable, breadth is another variable. These two are independent, not depend on one another. Next one, a set of points lying neighborhood of a point. A neighborhood means the set of points in the certain region. For example, neighborhood of a point a comma b means you take certain. So neighborhood of a point means if you take a point a comma neighboring certain region, the set of all points corresponding to the point. Suppose a comma b. Plane means in the order pair. Throughout our discussion, you always taking order pair because two variable function. Taking a point a comma b in the coordinate system with some distance radius delta. It is just like a circle. Take all inside points in a one set. That means the set of all order pairs x comma y such that the distance between the point and the corresponding point, whatever we are taking as a reference point, is always less than the distance delta square, because the distance between point on the circle and the center is x square root of x minus a whole square plus y minus b whole square equal to delta. Squaring on both sides, we get here delta square. Here we remove square root. X minus a whole square plus y minus b whole square equal delta square. If the point inside, that means the distance is less than delta square. Strictly, you collect all the points which, which are inside the boundary, inside the circle. This is called a neighborhood of a point a comma b. It is usually denoted by b of a comma b with a radius delta. This set is denoted by. This is the first definition. Next, limit of a function. Limit of a function as usual. For every epsilon greater than 0, there exists delta greater than 0. In single variable, we know what is the limit of a function. That means limit of a function means f of x tends to L. F of x has a limit. That means limit extends to some point A. F of x equal to L means for every epsilon greater than 0, there exists delta greater than 0, such that modulus of f of x minus L less than epsilon whenever 0 less than mod x minus a less than delta. X minus x tends to a means you take x minus a less than delta. This is the definition. In case of two variable, you just replace f of x with f of x comma y, and here x is replaced with order pair x comma y, and a is replaced with a comma b. That's all. The same manner, just replace f of x in terms of f of x comma y. You see what is the definition for the limit of a function in the two variable. It is similar as that of single variable. Limit extends to not x, here order pair, because two variable function. F of x comma y equal to L means, it means for every epsilon greater than 0, there exists delta greater than 0, such that modulus of f of x comma y minus L less than epsilon whenever 0 less than mod of x comma y minus a comma b is less than delta. This value nothing but distance between 2 points. So distance between 2 points is square root of x minus a whole square plus y minus b whole square less than delta. Squaring on the both side. It becomes 0 less than 0 square, nothing but 0. X minus a whole square plus y minus b whole square less than delta square. You can write either this condition or this condition. In the definition, most of the time we represent this condition. Both are equal. Okay. If the limit, after finding limit, you observe that this limit value equal to function value or not. If it is equal to function value, then we say that the function is continuous. Otherwise, we say that the function is discontinuous. This is the two definitions, continuity, limit. Today we are going to discuss about this limit and continuity and their related problems. Okay. So very easy topic. Everybody must learn problems based on this. Okay. See problems. Before going to problem, just I give a procedure better. You can easily handle. Otherwise, at the time of problem section, you may face some problems. That's why I'm telling you here. I provide the small procedure or process. First, finding the limit of a point at a limit of a function at a point. First, substitute y tends to b in the function. After that, substitute x tends to a in the resultant one. We get some value. If you get some finite value, we are happy. If it is an infinite or does not exist, no need to find other things. You simply write down limit does not exist. If it is exist finite, then you find next value. First apply the x value. Previously we apply the y value. Y tends to b first. Now here we apply the x tends to a first. Then y tends to b. We get some finite value, we are happy. Otherwise, if you are not getting finite value, simply write down limit does not exist. If this is finite, this is also finite, you observe that these two are equal or not. If these two are equal, you go for the next step. Otherwise, you simply write down limit does not exist. So at any stage, the limit does not exist may occurs. So if these two are equal, then go for the second step. In the second step, substitute y equal to mx. That means y is a function of x, or y equal to mx square in the function. That means converted into a single variable function. Limit x tends to a f of x comma h of x. Observe that this is exist or not. If it is exist, happy. If it does not exist, stop the process. Limit does not exist. If it is exist, after observe that existing value equal to the previous existing values or not. If existing value is equal to the previous existing value, then we say that the limit exists. The corresponding value is equivalent value. Whatever exists equal to the limits, you write down the limit value is same thing. Here we are going to discuss about the first problem. This is the first problem. Find the limit. Find the limit. So answer. Answer. Let what is f of x here? Given function 2x square y by x square plus y square plus 1. What about x value? X tends to 1, x equal to 1. What about y value? Y equal to 2. Here they provide x equal to 1 and y equal to 2. And then start the process. Step 1. First find simultaneous limit. Limit x tends to 1, f of x comma y. Limit y tends to 2. We need this limit first. Limit y tends to 2. Limit x tends to 1. Substitute the function value 2x square y by x square plus y square plus 1. First evaluate the internal limit x tends to 1. See what happened, or what is the resultant of function. Substituting x value, it becomes 2 into 1 square plus y by 1 square plus y square plus 1. Now then substitute y value, otherwise first simplify, then substitute. This becomes 2y plus y square plus 2. 1 plus 1, 2. Now substitute y value. Y value becomes 2 into 2 by 2 square plus 2. 4 by 6. This is equal to 2 by 3. One limit value, limit y tends to 2, limit x tends to 1, f of x comma y value is 2 by 3. Finite value. Now we find other limit. Interchange the limit rule. Limit x tends to 1. First apply y limit, then now this limit. Limit x tends to 1. Limit y tends to 2. F of x comma y means 2 x square y by, write down the function value, x square plus y square plus 1. First find internal limit, which is equal to limit x tends to 1. Internal limit value becomes 2 into x square into 2 by x square plus 2 square plus 1. Now the limit value is limit x tends to 1, 4x square plus x square plus 5. So substitute x value, 4 into 1 square by 1 square plus 5, 4 by 6. What is the resultant value? 2 by 3. Observe that these two are equal. We are happy. Go for the second step. Here, if these two are not equal, you simply write down limit does not exist. X tends to 1, limit y tends to 2, f of x comma y value is same as limit y tends to 2, limit x tends to 1, x tends to 1, f of x comma y equal to 2 by 3. Now you go for the next step. Usually in this step, we equate the y equal to mx, y equal to mx or y equal to mx square. Is there any possibility y equal to substitute y equal to mx? Usually most of the time we substitute y equal to mx. Put y equal to mx. If y equal to mx, if x value tends to 1, then y value tends to m. So you see one more, I made a small mistake. This condition is verified at origin only. No need to verify this condition here. These two are equal, therefore simply write down, therefore limit x comma y tends to 1 comma 2, f of x comma y equal to whatever we get. That's all. See, third condition verified if the point origin. Second condition. This second condition. You go for the second condition if the given point a comma b is origin. Find the limit at origin. Then only we go for the second step. Otherwise, you stop in the first step only. First step enough. This is enough. If a comma b not equal to 0, first step is enough. Otherwise, you go for the second step. Okay, that's all. So stop the process. The limit value is 2 by 3. Next problem. You see xy by here origin. Whenever you see the origin, that time only you are some. Keep your mind in some alert manner. So here we need a second step also. First find first step values. Here I am not writing all the procedures. Simply I find x tends to 0, limit y tends to 0, xy by x square plus y square. What happened? This value x tends to 0, numerator x into 0 by x square into 0 square. Finally, this value is limit x tends to 0, 0. X into 0 by means 0. 0 by x square. X square is non-zero value until substituting x value. So 0 by non-zero value is 0. So limit x tends to constant function is limit value same. So interchange the limit. Y tends to 0, limit x tends to 0, xy by x square plus y square. First substitute x value. Limit y tends to 0, This value is 0 into y by 0 square plus y square. Here also limit value is 0. Limit y tends to 0, 0 equal to 0. Now these two are equal. We go for the next step because we are here finding the limit value at origin. Here these two are equal. If these two are not equal, no need to go for the next step. You simply write down limit does not exist. Go to the next step, equal to 0. F of x means given function. This is f of x. You write down all proper steps like first problem. Next step, put y equal to mx. Therefore, f of x comma y, here x comma y value is xy by, I think, x square plus y square. This is the function. Put y equal to mx in f of x comma y. Then we get f of x comma y value mx. That means x into mx by x square plus mx square. X square is common factor in the numerator, x square into m. In the denominator, x square is common factor, 1 plus m square, mx whole square. That means m square. X square get cancelled. Finally, this value becomes m by 1 plus m square. It is independent of origin. Therefore, limit x comma y tends to 0, 0. F of x comma y in this case is f of x tends to 0, y obviously tends to 0. Put x equal to 0, y must be 0. M into 0 equal to 0. So therefore, no need to write down two limits. It's enough. In this case, f of x comma mx value is m by 1 plus m square. Here, there is no any x, so independent. What is m? M is arbitrary. You take m equal to 1. I take m equal to 1 by 2. I get one value. You get one value. Some other person put m equal to minus 2. He gets some other value. So this is not unique value. So limit means always get a unique value. But by substituting 1, we get different from the previous value. Our limit value is 0. If you get m equal to 1, we get other value other than. This is not a unique value. It provides infinite number of values. Independent of, it is variable. M is a variable. Therefore, limit does not exist. Limit at origin of the given function xy by x square plus y square does not exist. Does not exist. At the origin, most of the problem they ask at origin. That's why you must remember this procedure. If it is not origin, no need to find a second step. In the first step, only stop and write. If these two are equal, write down the value. For example, third problem. This is also at origin. See the third problem. Problem 3. Continuity is the extension, small extension. Find L value. Observe that L value is equal to function value or not. If it is equal to function value, we are happy. The limit is the given function is continuous at the corresponding point. You simply write down. Now, here also, f of x value is this one. I don't write down f of x as x tends to 0, a value, b value. Yourself write down all the things. In the examination point of view, I am directly going to find x tends to 0, limit y tends to 0, f of x comma y value. Limit x tends to 0, y tends to 0, because here limit are x value 0, y value 0. X times of y minus 1 by x square plus y square. That implies limit x tends to 0. This limit value substituting this limit, x times of 0 minus 1 by x square plus 0 square, which is equal to limit x tends to 0 minus x by x square. X get cancelled. Finally, we get limit x tends to 0 minus 1 by x. What about minus 1 by x? Minus infinity. It is not a finite value. Not a finite value. No need to find out other limit. Simply write down limit does not exist. If you have any special interest, you can find other limit also. Otherwise, here stop. not a finite value. Therefore, limit does not exist. If you have any special interest, you can find other limit, observe the existing value. Existing means finite. Here we get a infinitive. Therefore, limit does not exist. Even though just I am telling you for the understanding purpose, other part also, x square plus y square. First substitute x value. X value becomes 0 into y minus 1 by 0 square plus y square. Limit y tends to 0. In the numerator 0, denominator y square. 0 by y square is 0, equal to 0. See, here we get minus infinitive. Here we get plus infinitive. These two are not equal. Therefore, limit does not exist. Here, limit x tends to 0, limit y tends to 0. F of x comma y value is different from limit y tends to 0, limit x tends to 0, f of x comma y. Therefore, limit does not exist. Limit of f of x comma y at the point 0 comma 0 does not exist. Does not exist. This is the process to find the limit at origin. At origin only you keep alert. You follow the all the two steps. In case of other than origin, only first step is enough. Next problem. Next problem. Verify at the origin. Next second problem is also at origin. You must keep alert because we need to verify two conditions. Here also I am not giving f of what is f of x. Already they provide the f of x. Point also x comma y limit we need to verify at origin. That means a comma b value is a value is 0, b value 0. So find answer. Limit x tends to 0, limit y tends to 0, f of x comma y, which is equal to limit x tends to 0, limit y tends to 0, f of x comma y means x minus y by 2x plus y. Limit x tends to 0, y tends to 0 means x minus 0 by 2x plus 0. Limit x tends to 0, 1 by 2. That equal to 1 by 2 because it is a constant. Next, interchange the limit. First substitute x value, then y value in the function. If you have any confusion, give a equation number 1. Limit y tends to 0, limit x tends to 0, f of x value is x minus y by 2x plus y. Substitute this value in the function. We get limit y tends to 0, substituting x value 0 minus y by 2 into 0 plus y. Now what happened? Limit y tends to 0, minus y by plus y. That means limit y tends to 0, minus 1 equal to minus 1. See, these two are different. Both are exist even though they are not equal. Here, limit extends to repeated limits. These are called a repetition of the limits. The function value, this is different from limit y tends to 0, limit x tends to 0, f of x comma y. Therefore, limit does not exist. Limit x comma y tends to origin. Given function is, I think, x minus y by 2x plus y does not exist. Does not exist. Does not exist. Does not exist. That's all. So next problem. Continuity also, first you find a limit if it exists, and then later verify the limit value and function value at the point is equal or not. Third problem, continuity. We must find limit first of all, continuity also. This is very small topic. Most of the problems asked at origin. So you keep in your mind, if at origin we need to verify y equal to f of y equal to mx conditions also, y equal to mx or y equal to mx square based on the problem. Most of the problem y equal to mx. Second condition verification. Here continuity. Later we will first find limit. Whenever you see the continuity, first before we need to find limit. As usual portion. Here also at the point 1 comma 2, not origin. Limit x tends to 2, limit y tends to 1, limit x tends to 1, y tends to 2, f of x comma y. Limit x tends to 1. Limit y tends to 2. F of x comma y value is x square plus 2y. This is at not equal. Tends to means not equal. It is nearer but not equal. X tends to 1. Find this value. X square plus 2 into 2. That means limit x tends to 2, 1, x square plus 4. Substitute this limit value. X tends to 1. That means 1 square plus 4, which is equal to 5. One of the repetition limit is 1. 5. Find interchange the limit. Now y tends to 2, limit x tends to 1, f of x comma y. Limit y tends to 2, limit x tends to 1, x square plus 2y. X square plus 2y. That implies limit y tends to 2, substitute x value, 1 square plus 2y. What happened? Observe that. Limit, substitute y value, because we have only one term, no need to write down all the steps. 1 plus 4 becomes 1 plus 4 becomes 5. See, both are equal. Therefore, limit x tends to 1, limit y tends to 2, f of x comma y equal to limit y tends to 2, limit x tends to 1, f of x comma y. This value equal to 5. Thus, that means limit exists. Limit x comma y tends to 1 comma 2, f of x comma y value is 5. Limit exists. The limit value is L value is 5. Observe that function value. What is function value at origin? At 1 comma 2. At x 1 comma 2 function value is 0, but it is different from 0. But f of 1 comma 2 value is 0. Here L value is 5. Therefore, these two are different. Therefore, limit exists but not continuous. Thus, limit value, this value is 5. It is different from function value. So, the given function is not continuous. So, the given function is not continuous at point 1 comma 2. That's all. Not continuous means discontinuous. Last problem. Investigate the continuity. Last problem also investigation of continuity. Here also, so I verified for second one. Okay, this is third one, continuity. Investigation of continuity. Similar problem. This problem is also not continuous because limit does not exist. Easily we can identify the limit exists or not at the origin because it is a homogeneous. So adding degrees in the numerator, x degree 1, y degree 1, 2. In the denominator, x first term degree 2, second degree term 2, equal degree. Take a degree common in the numerator, total degree, in the denominator, total degree. Here 2, 2, 2. Each term degree is 2. That means numerator total degree 2, denominator total degree is 2. 2, 2 get cancelled. Therefore, it is homogeneous. Therefore, limit does not exist at the origin. This is the way. If the limit exists, then only we verify the continuous or not. Before limit does not exist, no, there is no meaning to about the continuity. Anyhow, first always we need to find limit x tends to 0, y tends to 0, f of x comma y. This value exists because limit y tends to 0. In the numerator, we have product xy by second condition fails. This value is 0. X tends to 0. Y value 0 means x into 0 by x square plus 0 square. That means limit x tends to 0. This is 0 equal to 0. Next, limit y tends to 0. Limit x tends to 0. F of x comma y. Limit y tends to 0. Limit x tends to 0. F of x comma y means xy by x square plus y square. Substitute first x value, then y value later. 0 into y by 0 square plus y square. 0 into something equal to 0 in the numerator. Denominator is non-zero. 0 by non-zero value 0, 0. Both are exist. But at origin, we need to go for the second step as per processor. Here, from 1 and 2, these limits are exist and they are equal. So go for the other step. Other step means put y equal to mx in f of x comma y. Therefore, f of x comma y, f of x comma y value is xy by x square plus y square. Here, now f of x comma y value becomes mx. X into mx by x square plus mx whole square. Numerator x square common, denominator x square times of 1 plus m square. X square get cancelled. We get m by 1 plus m square. M is variable quantity. Now our intention is find limit value. Limit x tends to 0. X tends to 0, y obviously tends to 0. That means you understand that in this case, the order pair x comma y tends to 0 comma 0. F of x comma y value is same as limit x tends to 0. If x tends to 0, y obviously 0. F of x comma mx. But x comma mx value already we know. Limit x tends to 0. This value is m by 1 plus m square. 1 plus m square because it is independent of x, but it is arbitrary. Suppose you take 1, I take 1 by 2, another person take 1 by 3. So it gives the different values. Here m is variable. Therefore, limit does not exist. Here m is arbitrary. So limit does not exist. If the limit exists, then only we can observe this continuity or not. Hence, it is not continuous. Is not continuous. That's all. If the limit exists, even though it may continuous or not, because limit exists means it gives the finite value, limit value. After that, observe that this finite value is equal to the function value or not. If it is equal to function value, then we say that it is continuous. Otherwise, we say that not continuous. So these are the problems in the limit and continuity. You can practice more problems. If you have any interest, you follow the Gravel Higher Engineering Mathematics by Gravel textbook, your prescribed textbook. It is also available online. You can download, the free downloading is available. You can download based on your syllabus. You can prepare the prepare the notes using my video lectures as well as a textbook. It's better.